So hi everyone, today we are exploring how 3D vision technology is changing the game for Malaysian manufacturing from semiconductors to solar and electronics. So joining me here is our Miss Jessica from SmartRay.
Hi.
So thanks for being here, okay? For the first question, 10 years of industrial markets and factory automation, you have seen the evolution of sectors like semiconductors, solar and electronics. So in Malaysian context, what challenge are making 3D technology increasingly relevant?
So over the past decades, I have observed that Malaysia industry, especially in the semiconductors, electronics, or even in the solar and EV, that has transited from actually more precision-based manufacturing than just a volume-based. So as a component, actually getting smaller and more complex, like microchips and even battery modules or even the PCB. So the margin for the error is actually shrinks. So traditionally, the 2D inspections often struggles to keep up with the in-depth complexities of their inspections as what is in today's markets. So that is where the 3D inspections vision systems come in. So the 3D inspections actually offers higher resolutions, more in-time analysis, and which is critical for the defects detections and even surface inspections and dimensional measurement. So sector that actually leading to these kind of adoptions in Malaysia, it would be like, for example, in the semiconductor industry, which is the wafer level packaging demands is also increasing, and the electronics, especially in the SMT and also connector inspections, that would actually relevant to this, and in EV and also battery productions is also relevant, is because of the safetiness would impact actually the life of the users or from the product itself.
Oh, I see. So based on these sectors, right? Which sectors are moving towards this adoption and why you think that?
I think that for the sector that is relevant is including like semicons and electronics, and also in the EV relevance industry as well. So that's in Malaysia's context, that SmartRay sensor is actually relevant in the spec that it is designed for more inline inspections, which is it's provide the micron levels of the accuracy, and with the robust of the algorithm designed for detecting the high, even the volumes and also the surface irregularities. So our operance architecture is also relevant to the user in terms that they have they are open to connect to their software, and they don't really have to overhaul with the entire process.
Okay, so next question. Coming to Malaysian manufacturers, what are the most common needs or priorities they share regarding to the quality inspection?
So in the Malaysian context, what we have actually facing from our customer, usually they are using the 3D for detecting the surface like height defects, or even the depth, and also some bump, which they want they cannot really achieve with purely 2D system. Or some of the cases they want to check the force reduction, the force rejection rate, so that try to avoid some over reject from their productions.
So the third question is, industries like semiconductors and electronics, precision and consistency are non-negotiable. So how do you demonstrate measurable value of the 3D vision than the traditional 2D inspection or manual processes?
Okay, so we typically benchmark the performance in two areas, which is first is the defect detection rate, which the 3Ds are actually often identify the surface height of the defects, and also some voids that 2D system usually miss out. And then on the other hand, we also focus on force rejection reduction rates. So with better and also more in-depth analysis, 3D trying to minimize the unnecessary reject, which also costs actually monies to the manufacturer. So with your 3D visions, we capture the complete actually a z-axis data, which is we call it depth, and allowing actually more accurate measurements of the complementarity and gap and flushness, and even some volumetric levels of analysis from, for example, like shoulder paste or even the adhesive. So for example, a 2D system might pass a shoulder joint. They're able to detect the shoulder joint, that whether it's look good or not. It's more on the cosmetic side check. But on the 3D vision system, it can actually detect the insufficient shoulder volume that actually leads to future electronics failure. That is what 3D is coming into place.
I see. Okay. So next we have manufacturers are always in a dilemma due to multiple factors. So what type of approaches do you use to address these concerns and build confidence in adopting the 3D vision that you say?
We understand that actually traditionally customers tends to be more, I would say, reluctant to move into the 3D, considers the complexity that have to move into. And then to address these concerns and also build customer confidence, we take a more structured and consultative approach to focus on building the confidence and also reducing the risk of them to the failure of applying that particular 3D system. So firstly, we will start with listening the inspections needs that they need to access. So it depending on what they really the challenges they actually facing. What are the defects they want to check today? What are the scrap or also the rework rates, and what levels of the automations that their customer is needing. And then later, our technical team will come into place where we will do a POC, which is a proof of concept to our customer with a sample test. For instance, we will collect the samples and that understands what are the criteria that need to inspect, and our engineer will help to do the in-house evaluation. So with the comprehensive of the sensor line in our test lab, they can just do the concept and also the POC testing in our test lab. Then this is where we shows the result to them. And then after they successfully adopt or also they apply our system, that is not end of story yet. Our technical support is actually continuing, because sometimes where the sensor is applied in line and the machines in the buy-off process, there will still be a continuing improvements is needed. Our team is always ready there to do the continuous support to our customer.
So how do you communicate that 3D vising is not just a cost but an investment that delivers strong returns while maintaining the speed and the accuracy?
Okay, so we position actually 3D visions as a strategic enabler. It's not purely an inspections tool. So for instance, we help to quantify, like for example, the reduction in the rework and the scrap, which is the customer can visualize the number itself, and also the lower of the manpower dependency will actually help them in the saving the cost for a periods of time. And then it's also helped to improve the product quality. It's because of those which are defects. It would be rejected at the early stage of the production, so there is no continual wastage of the material from this stage. So take an example. For instance, the electronics manufacturers who adopted the 3D visions in their inlines PCB shoulder inspection. So this can help to improve the yields and the force rejection rate. So from this perspective, actually it saves their cost of the manufacturings and also the productions. So the cost of the system itself, it can be recovered within a periods of time. Take example like 2 years. So the reworks and increase of the throughput, it's actually improving as well. So from this perspective, they are saving the money, not purely looking at the system cost itself.
So, can you like share a success story where a customer saw a tangible ROI in the short time frame?
I will say that in the industrial practice, the ROI is actually not going to be like it's the 3 months or the 6 months time, but it can be the example. For example, that's what I mentioned earlier. The PCBs manufacturers who apply the 3D inline inspections, they can see the savings itself from the reductions of the rework, and that is lower wastage of the material and also a lower dependence on the humans' manpower.
So, last but not least, in coming foreseeable future, what major quality control or automation challenges do you expect in Malaysian factories to face?
What do I see from the markets from time to time that for currently in my perspective, I see mainly three challenges. The firstly is the components miniaturizations, which is, for instance, for now the sample is getting smaller and smaller. For example, the PCBs or SMT that are getting smaller and smaller, so it's they are requiring higher precisions and better resolutions from the 3D sensors. And then in Malaysia, we also have skilled labor shortage, where it's actually they pushing the markets to the needs of more intelligence and also automate inspections. In another perspective, I also see a data-driven manufacturing, which increasing the pressure to analyze the result or even the failure and reports the quality data in a more real-time basis.
So, how is SmartRay positioning itself to support customers in meeting these future challenges?
So the SmartRay is actually preparing ourselves in the perspective that we are continuously improving our sensor capability to a higher resolutions and also in the faster speeds. And we are open to connect to software like even Helcon, Matrox, and even LabVIEW, which consists of the AI-based defect classification. So we are also investing in the Industrial 4.0 capability. So that our solution is not only inspection itself, but also feeding the intelligent data back to the production ecosystem.
So I think that's all from Miss Jessica. So thank you, Miss Jessica, for sharing your insights. So to learn more about SmartRay, visit our website and see you next time.
Thank you.